Here's another example of using a piecewise defined function to represent an absolute value function. So we've got the function f of x is equal to the absolute value of x plus 2. And we're asked to first define a piecewise defined function for this. Now, you should watch the previous video if you haven't yet. But if you have, then this is going to make a little bit more sense, because I'm going to say that the absolute value of x plus 2, defined as a piecewise function, is equal to x plus 2 when x plus 2 is greater than or equal to 0, and it's equal to the negative of x plus 2 when x plus 2 is less than 0. So this is equivalent to saying the following, and this is how you would see it written in a textbook. Just like that. So this over here is our piecewise defined function. Now we'll go ahead and sketch a graph for that guy out. So our split line, or our line of division here, is at -2. So at -2, we've got this vertical line. Well, it's imaginary, right? It's not really there, so we'll delete it later. Or you can just, think about this as not really being there, but it helps us see the division between the two. So now that we have our division line here, what we're going to do is we're going to graph x plus 2 to the right of it, and we're going to graph negative x plus 2 to the left of it. So over on this side right here, we've got the graph x plus 2. On this side, we've got negative x plus 2. So we'll start plotting some points. Okay, when I plug in -2, I get 0 out. Okay. When I plug in -1, okay, I get 1 out. When I plug in 0, I get 2 out, so on and so forth. So this is this graph. Now when I plug in -2 over here, I'm going to get an open circle, but I'm already closed at 0, so we're good there. Then over here, when I plug in -3, I get -3 plus 2, which is -1, minus a -1 is +1. Okay, and if I keep going, you're going to see that when I plug in -4, I get +2 out, so on and so forth. And so there's my v value that you would normally see when you take the absolute value function. You shift it to the left 2 units.